Hello.
Welcome to office hours. Oh my gosh. Welcome to office hours. Thank you so much for joining. I see you. Oh my gosh. All right. How are we doing? Oh, so Alyssa was able to do 99 plus 5. That was exciting.
You did what?
I posted a video.
Yeah.
I'm getting more tech savvy.
Yeah. It's
Yeah.
exciting. You're really getting it.
Yeah.
Well, this
So
morning was the first time I got to get on the community, and I found all those multiplication problems. I'm so happy.
Yeah.
Yes, I'll be working on those today and tomorrow.
Yeah, I try to have the out there so it's just easier to be. Yep.
Just
Oops.
I've had so much PT and everything, and it's just trying to get my rhythm and get to do everything else.
Yeah.
So
So, Alyssa, did you want to talk more about the chaining? So does it make sense, the chaining equations?
yes, it is starting to make more sense. So but as I was doing that problem,
Can
hold on,
can
Ava.
I tell you something?
What, Ava?
Wait, mommy has to tell me first, and then you can
Yep,
tell me.
99 plus 99
No.
equals
Mommy goes first.
198.
Mommy goes first.
Yeah, I get to go first. You have to take turns, Abram. Can you do that?
But
So-
I just told her.
Yeah, but you told me the process of how you figured that out last night.
Okay, the process.
No. You have to wait. All right. So it was kind of cool. She said, I don't know. Yeah, Tammy, take a look. There's a little video. She put in a little video just to be able to explain how she was doing it. It was great. Okay.
well, I
So
will go back and watch that video then when we get done.
yeah, it was pretty good. What else? So you okay, so that's what the other things is. I gave you some what is it? Some multiplication questions. Yeah, I think I did it for like an extra in bonus resources.
Mhm.
Yeah. Oh yeah, I see you now. Okay, yeah. So when you see it, it's all there. How else are we doing? I've been working on division for quite some time. I still got to do is I still have to get my second grade book 2 out the door. I'm changing the format a little bit. I'm going to put the answers online so then the kids don't see what the answers are.
Okay.
That's all. So I just want to make sure that the kids don't see the answers. And then but the answers are free. Just getting them to understand it. That's all. All right. Okay, so other than that, what are we working on? How are you working on, how are you working on stuff? Oh, that's right. Somebody needed to, what was it? Heather wanted to talk about the two-step equations. Oops.
Which is training now.
Yeah, chaining. Yes, sorry. Thank you. The chaining equations. Um, is Alyssa back?
I'm back.
Yes.
I've been talking to him, telling him what he can and cannot do.
Yeah.
So hopefully this will work. If you see me muting myself, then we haven't solved that issue very well. So anyway.
Okay. Thank you for muting.
Yes.
I do appreciate it.
So
Okay.
when I did that problem, and I've watched you do it, but the aha moment was watching myself. Maybe that filming was good because I
Yeah.
watched myself do the problem. And when I moved my finger over, when you did 99 plus 5,
Yes.
and you took the plus the 10 and it changes to a 1, what it automatically looked like is that you're starting over with 9 as the top number and the plus 1 is that bottom number.
Yes.
Mhm.
Okay.
Exactly.
And that is what the chaining is. And so then you're starting all over and you're saying, well, plus 1 is plus the 10 minus 9 after that. So that was my aha moment in that, because I would ask you, oh, can you do the video for me and stuff like that?
Yeah.
But then I just sat down and I started writing what was it, 96 plus
Yeah.
5. And
Yeah.
I would go 97 plus 5. Then I would
Yes.
go with 98 plus 5.
Nice.
And then when I got to the 99,
99 plus 5. That was
Yep.
so then we started having Avram talk about it.
Good.
I mean, teach him a little bit, and I think he started to get it a little bit more. So
on the 2-step, you mean, Mom?
Yeah, the 2-step. Did you want to
The
tell her what you learned?
chaining equation.
Did you want to tell her what you learned about on the abacus?
I forgot what I learned.
He forgot. He kind of started to get it, but then he took it to a principle further. It wasn't with the abacus, but he was talking about plus 1 in there.
Yeah, good.
So I don't know. Avram,
Uh,
you're welcome to share it, but you have to keep it to that.
okay.
Can you do that? If you can do that, then I'll let you talk. If you can't, then
So
we'll.
99 plus 99. How I did that is the one from the 99, I put it on the other 99. That will equal to 100. So I just put them together and 199.
98.
98, yeah.
Yeah, he wasn't necessarily doing that with the abacus, but he knew.
There's this long piece of white hair.
Okay, so that's fantastic. 99. And then you added the 5. Okay, what happened? Now, what we could do is a chaining equation. If we did, here would be a great one. And I don't know if we can do 95 plus 9. So 95 plus 9 would be the question. And so this becomes where chaining becomes even more extensive. So we have 95 on the abacus.
Yes.
How do we add the 9?
Well, it's gonna. We don't have enough beads, so it's gonna be 10 minus 1. You got to add 10 to take away 1.
Okay, so now here's the one thing that I was trying to, I think I need to explain this a little bit more, is when we say 10, if you
Mhm.
notice, it's actually 2 digits, 1 and 0. 1 and 0.
Correct.
So when we line it up, when we say plus the 10, that 0 pushes the 1 from here to here. So we want to plus the 10 minus the 1. So now, which one do you want to do first? The 1 or the 10?
The 1.
Okay, so let's
If
subtract.
that's not how I know. Yeah, let's go ahead because it's a single number.
Yeah. So let's subtract the 1 first. And this is why it's called chaining, because we take that 1 and we want to minus the 1 here, and we cannot do it. So to
Right.
minus the 1, what do we do? Minus the 1
Minus
is equal
the
to,
5, minus the 5, and add the 4.
yeah. So minus the 5 and plus the 4. That is one chain. The second chain is this one right here, but it's actually this 1. So you want to add the 10 here. So
Correct.
plus 10, which is also plus 1. So how do we add the 1 here?
So it's going to be add the 10 minus 9.
Minus the 9 plus the
Yep,
8.
plus the 10 minus 9.
9.
That's where we do it again. So you minus the 9
Mhm.
and you plus the 10. And so my final answer becomes
104.
104. That's it. So, Alyssa, when you're ready, instead of doing 99, do 95 plus 8. 95 plus 8. So this would be the next set. 95 plus 8. 97 plus, 95 plus 7. And then 95 plus 6. That would be the next set to work on.
Oh.
Because this is where you get more than just the one chain.
Oh, okay. Okay.
Okay.
Okay, so that is the one thing that I noticed differently with you in your video. You explained the process of what the 1-0 is. But I was wondering if you can kind of repeat that again, because there was some verbiage that you put in there. You said that it's moved over.
Yeah. So just as I said here, when we line it up, we had 90, 95 on the abacus, right?
Mm-hmm.
And we want to plus the 9 here. But if you notice, we want to plus the 9, we need to do plus the 10 minus the 1. Notice what 10 looks like. 10 is a 1 and a 0. That 0 is what pushes this 1 to the next column over. That's all we're doing is pushing this 1 to the next column over. So this is not necessarily 10. This is actually 1. So when we talk about it, it's actually 1, 0. We want to plus the 1, 0 and minus the 1.
Okay.
Because we don't talk about 10 as one whole number. It's actually 2 separate digits. So when we look at the 1, when we look at the 1 that happens to be part of the 10, it's still just 1.
Okay.
That's all. But I think that's a more of a adult concept than a child concept.
I think that, well, and that's why I found myself because I once I did the work for in the ones place, where you
Yes.
have minus that 1,
Yep.
then you're working on the next column over. So it's kind of almost as if you're starting all over, but you're not. You're just finishing what you're doing the next part of the plus 10.
Yeah. It's actually not starting over. It's taking you're using the bottom number, which happens to be this. I'm sorry. So you're not starting over. You're just doing 9 plus 1 and you're utilizing that bottom.
Yeah,
that
that's what
bottom
I'm meaning. That's what I mean. I'm just continuing. There we go.
Yes.
I'm continuing with the next chaining, basically. That's
Yes.
what I'm doing. And visually, with the circles, that's kind of what you're talking about with the chaining.
Yes. Yes.
So, because if you did a 999 plus, because you had a video where you had, I think it was 4 9s, and then you added 2 9s to it.
Yeah.
And you're doing that. So that kind of explains a little bit more of how you have your book written out here. With the
Like that?
circles and the, yeah.
Oh yeah. Yeah. With the circles. Uh-huh. Yeah. So I think, yeah.
Also in this problem, I noticed that we're starting from the right.
It's a single digit. That's really all you can do.
Yeah.
In a single digit.
Well, it's 4 9s, and you're adding 2 9s to it. So
What?
you have 900.
Oh, wait. Are you talking about this?
Yes.
Oh,
Yeah.
okay. We start from here.
Oh, you are starting from there?
Yeah, we start from here.
I would.
Oh, okay. Okay.
Yeah. I still start from here.
Okay, you still start from there.
Yeah.
Okay.
Did you guys get the email? Scheduled. It should have sent out today. Today's the 7th. All right. Okay. Anyways, I didn't get my email. All right. So yeah, I would still start from here. So when I'm looking at it, it'd still be plus plus the 9.
Mm-hmm.
So we have 99. It would be over here.
Mm-hmm.
Plus the 9 is equal to minus the 1 plus the 10. Minus the 1 plus the 10.
Mm-hmm.
Plus the 10 minus the 9. Plus the 10 minus the 9. And then I do it again over here. Now we've done with this one. Now we go here. Plus 9 is equal to plus the 10 minus the 1.
I see.
Yeah.
Okay.
Yeah.
That makes sense. Yep.
You
So
don't sound confident.
with that the initial one, you're minusing the 1, and then you go to the other part where you're going. Well, you're plus the 9 is plus the 10 minus 1, so you're minusing the 1 in that first.
Yes. Over here.
You're right. And then
Yep.
after that, then
And
you're
then
actually going to that second part where you're going plus the 1
Yep.
is plus the 10 minus the 9.
Yep.
So then you
Exactly.
start minusing the 9 after that.
Yep.
And then when you went back to that first one,
Yep.
because it was already broken up, it's still the same thing. It's plus the 10 plus the 9 is plus the 10 minus the 1. You went back to that first formula when you went back to the very end of the row.
Yep. There you go. See?
So
You're getting it.
Yep, I'm getting it. What is it? The the deer in the headlights
Yes.
has broken, and I can see it a
Getting
lot better.
dimmer.
Yeah.
Yes.
Yep.
That's funny.
I like to call it. I'm like, oh, what are we doing here? So yes.
Yeah.
But like, yeah, it's getting and but is subtraction a little bit easier? It seems like subtraction's a little bit easier with than.
Yes. Yes, because you just add back with what you've taken out
Okay.
and you could see it. So if we did subtraction, let's see, if we did subtraction minus 9,
Mm-hmm.
right? So it is, so let's do it. So we have 1. What do we want? There's no room to take away the 9. Minus the 9 is equal to minus the
Minus
10 plus,
plus 1.
right. So let's plus the 1 here, and then we want to minus the 10. We can't minus the 10. Minus 1 is equal to
Plus the 9.
Yep. So you plus the 9 minus the 10. Can't do it. We got to go back again, right? Minus the 9. And then here is where we take away the 10.
Oh, so plus the 10, plus the 9, minus the 10.
Yes. Yes.
So you're just doing it in reverse.
Yes, that's exactly what it is.
Okay.
It's crazy on how when you see the patterns. And so I was actually doing this with my student. It's so interesting to see patterns. So have you been getting Avram to count from 0 to 30 on the abacus?
No, I need
Okay.
to.
Yeah, get him to count and then get him to do skip counting. And let's do some skip counting of the 5s. So we do 5, 10, 15, 20, right? Do you see that there's a pattern? 25, 30, 35, 40, 45, right? And then 50. Do you
Mhm.
see the pattern?
Mhm.
So let's do it again, but this time we could do it. Let's add the 2, and then now we're going to count by 5s.
You just add the 2 in there.
Just add the
Oh yeah,
2 and
because you can add by 5 at any point is what you're saying.
yes, and then you get to see the actual number. So I'm going to add the 5. This is now 7. And then this is 12. You add the 5, now we have 17. Add another 5, it's 22. So you see the pattern. Do you see that? You add and then this is now 27, and then you add the 5 and you get to 32.
Okay.
You see the pattern now?
Yeah, now we're at 32, and then plus the 5 is 37.
Yeah,
37 plus 5 is plus the 10 minus
42.
5. So
Yeah.
that's 42. Now plus the 5 is 47. Plus the 5 is plus 5 minus 4. So you have 57 plus the 5. Yeah.
Yeah.
Then,
Interesting, right?
yeah.
Yeah. So yeah, get him to start counting on the abacus.
Okay.
Just to
And
get him
just,
to, and then have him count backwards, and then have him count like skip counting and stuff. I gave you a little checklist. Did you get it?
Yep, I got it.
Okay. Yeah.
Yep.
I get the kids to do the checklist, just to make sure. He'll go through it really quickly, but it would help just to get that. And then you can count to like, you can start them on like thousands, 348 plus 348 and count by 5s or something. Or 462, count to 478. And then count backwards, right?
Okay.
So you don't have to stay with the 2-digit,
Mm-hmm.
but then he's going to see how it just repeats itself.
Yeah, it does.
Mm-hmm.
Yep, I got that. So I got that in the email. Yeah, I should do it as a warm up.
Yeah, exactly. That's all it was meant for. It was only meant for a warm up. Just do a quick it should take them like less than a minute just to count. That's all. It's not meant to be a a full-on lesson.
Mm-hmm. Yeah,
Yeah.
makes sense. Yeah, we should have him work on that and do that. We've been kind of one of my classes ended, and so it's a little bit more laid back, and we can just actually just focus a little bit more on this.
Yeah.
And just take it really slow and casual. Just do a simple a simple skip. I don't want to call it a drill. I like just a warm up. Warm up sounds so much better than a drill.
Yes. It is just a warm up. It's not meant to be a drill. Like it's not like totally.
Yeah. So, yeah. So we can work on anything. We can work on multiplication. We can work on division again. I did go back over the video a little bit. So
good.
I needed to do it again so that I can just the verbiage and I just think I just had a mental block because one time I was able to explain it to my niece.
Yeah.
I just kind of got stuck. There was this one video that I watched that talked about distributive property in division.
Oh, really?
Yeah.
I would love to hear that one. I would love to see that one.
And
Did you see my? Okay, go on.
There was another one that was a little bit shorter. So, because distributive, what it's telling me is that once you've mastered distributive property in multiplication, then you will see how it's done in action in division.
Yes.
So, because they don't, Well, I don't think they do distributive property in division for, um, for
American Math,
mainstream.
yeah.
No.
Mainstream doesn't do distributive property in division.
Yeah,
Then that's where that one lady, did you see my reply video about how she broke it up and I showed you how I broke it up?
maybe I did. Maybe that's what you were meaning. Okay, so you commented on her video
Yeah,
itself.
that was the video. That was the I did a reply video.
Oh, on what she did. Okay, I will have to go back and look at it.
Okay, well, let's talk about it now.
Yeah, let's do it. Yeah.
So the question was, what's the question? 8073. Yep. 8073. All right. Let me go get my bricks and my blocks. Yeah. I did it a few times, but I finally oh, okay. I now know what I'm trying to say. So it was good to review. So the question is 23, and then we need to divide the 8,073, right?
Mm-hmm.
Okay, so how it was explained, we're gonna do 8. 1, 2, 3, 4, 5, 6, 7, 8, right? I'm gonna leave a 0 because I don't have enough to do it, but I have 7. 1, 2, 3, 4, 5, 6, and then 7. And then we have the 3 little cubies, and that's what this is. All right. So the way it was explained using the brick model, or what did she use? Those little rods and cubes or whatever?
Yeah, they were rod and
Yeah,
beads. Yeah.
it's still the same. So, but the first thing we're going to do on the abacus is we are going to figure out where our quotient will be. Where do you think our quotient's going to be? How do we find that?
Where you take the dividend and subtract it from the divisor.
Yeah. So there's
So we're
4,
going to have 2.
and then there's 2. So we're going to, yeah. So 4 minus 2 is equal to 2. Okay. So we know that we're going to our quotient is going to start in the tens column. I need a bigger abacus. I apologize.
Where's my bigger abacus?
Okay. Let's see if I can have enough room. I don't have enough room. Let me see if I can.
Okay.
There we go. All right. So you said 2. We're going to be 2. 1, 2. So our quotient is going to, our quotient is going to be right here in this column, in the tens column. Right? And
Yes.
then what we're going to do is we're going to put our dividend on the abacus to help us use as a placeholder. That's our placeholder.
Yes.
Don't worry about the place values. That's just being used as a placeholder. Okay? So the first thing we're going to do, first thing we're going to do is we're going to figure out, is there enough so the way she had it was, I know 2, so we're going to do distributive property. We're going to take this number first. 2 times something is equal to 8 or less. Can we do it? We can, right? If we can do it, then that means we got to make this a 0, 8. That means that from here, we have to go here because we have to incorporate that 0. Does that make sense?
Yep.
Alyssa?
Yep.
Okay, so now I know 2 times 4 is equal to 8. So I'm going to separate to 2 groups, right? Because we know it's 4. 1, 1, 2, 2, 3, 3, 4. Okay, so it's in 2 groups of 4 because that's what it is, right? 2 groups of 4, and I've taken away. Now the problem is whatever you do here, you got to distribute it to here. So we know what? We know 3 times 4, there's no more to take away. Because if you notice, there's a blank here, and then there's a blank here, and then there's 7 here. But this is what we need to look at. Okay, so I've taken away too much. That means that instead of taking away 4, I'm going to take away 3. Does that make sense? So I'm going to take away 3 instead. That's 6. And I have to add back my too much. And the too much is I took away 20 out. So I got to add back 20 to my thing. Does that make sense?
Mm. Mm-hmm.
So what I did was I took away the 8. It was too much. I had to actually make it instead of doing 23 times 4, it should be 23 times 3.
Correct.
But that means that if I took away too much, I have to add back 2.
Mm-hmm. Huh? Okay.
Okay. This is where it gets really exciting, because I figured now we see that this is what do you call it? Math facts, right? We get rid of the zeros, but what are we really trying to do here? So I'm sorry, let me do this 12, right? So we got to actually take away the 1. 220 is this number right here. We got to add this back over here. Ah, yes. Okay. So we remember that we have a minus here because this is what we do. And if we have 20 times minus 1, I wonder if that's the way. Maybe I should do that. Minus 1. Then you know that you're going to, 2 negatives will equal a positive, because we got to add back 20. So this actually turns out to be plus 20. I don't know. I got to play around with this a little bit. But so now what do we have is we have 2073. Does that make sense?
Mm-hmm.
That doesn't sound confident. Okay, so let's go back. Because what did we do? 23 times that by 4. We're going to distribute the property. We're going to do 4 times 2 times 4 is equal to 0.8,
Mm-hmm.
right? But if you remember, it's actually 20. So this would be 0.080, right? Because if this is 20, makes sense?
Mm-hmm.
So we do this one, we do 3 times 4 is equal to 12. We do 92. I'm going to draw lines to show you how they are, because we're on paper. Make sense?
Mm-hmm.
But notice it's taken away 92 is too much.
Mm-hmm. Mm-hmm.
So instead of taking away 92, we should try the next one. Let's go 23 times 3. So we do it again. 20 times 3 is equal to 60, right? Because remember, it's a 0.6. And then 3 times 3 is
0.9.
0.9. So then we get 69.
9.
But notice the difference between here and here is 2. So that's why we have to add back 20.
Right.
Do that one part again. The difference between.
The difference between 8 and 6 is 20.
Oh, yes, 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 yes. 'Cause
right?
you're subtracting, yep.
So that's why we got to add back 20. That's why we got to add back the 20 on the abacus. That's why we added back 20 in the bricks,
Mm-hmm.
because I took away too much. Remember?
Mm-hmm.
If I had 4. I took away too much. I have to add back the 20,
Ah, okay.
right? And I take away the
Yeah.
16.
There, that's why it gets, okay.
Okay. So that's why we're back to 2073.
Uh-huh, okay.
Okay. Now what we're going to do, that's what this is. Now what we're going to do is this now changes to a 3, right? So it'd be 3 times 3 is equal to 0, 9.
9.
Minus the 9 here, because it says 0, 9, minus the 9, minus the 10, plus the 1.
The 1.
Got it?
Mm-hmm.
Okay. So now we're left with 1, 1, no, 1. Is that right? 1, 1?
I thought it was
1.
161.
Is it 171?
No, I think I bumped my.
Yeah, I
think I
bumped it too. So let's go back.
Yeah.
8073.
3.
I know I bump it because I'm moving around stuff. So I take away,
Mhm.
that's too much. I add that and then take away 9. Oh, so 1173.
Yeah. Okay.
We good?
That looks better.
Yeah. Okay. So let me write that down. So we have 23, 1173. We're still back to, but we're going to keep the 3 here. Oh, sorry. Yeah. Okay. This is where we do the advanced stuff. We know what? We know 2 times what is equal to, oh, no, I'm good. No, we're good. 2 times what is equal to 1. Does that work?
No.
No. So that's how we got to bring down the next number. So now our new number becomes 11. Two times what? 2 times 5 is equal to 10.
Mm-hmm.
So I add my 5. That's my quotient. Take away 5.
Be way too much.
No. 3 times 5 is equal to 15. Take away 1. Take away 5.
Never mind.
So what do we do here?
I
We
heard
did 1,
something, so I wrote it
1,
down and said what it was
5.
supposed to be.
Yeah, I was thinking it was a different one. I was working on a different one.
So you have to put the 5 back.
No. We don't have to put the 5 back
No, you don't.
Okay.
because it was 117. We have enough,
Oh, 1,
right?
1. Okay.
Because 23 times that by 5 is equal to 1151.
Oh,
So
okay,
if
okay.
you notice the progression, 23 times 4 is 92. 23 times 3 is 69. 23 times 5 is 115.
Mm-hmm.
So this is why she did the list first,
Yeah.
but I didn't.
Well, there was this one. What was this
Wait,
one?
let's finish this.
Yep.
Okay, so what did we do? I'm sorry, I completely forgot the bricks. So we took away the 9, we changed this out, and we made this right. So we had 1, 1, 7, 3. 1, 1, 7, 3. That's what we did. So we took away the 10 because 2 times 5 is equal to 10. So take out the 1. And then 3 times 5 is equal to 15. Take away 1, take away 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 15, right? And then we're left with 23.
Oh,
So then that would be 1. Does that make sense?
Mhm.
and then it's three. So it's 351 is the quotient.
Yes. So the quotient is 351.
I got to use my 13 column.
351. Hello, Evelyn. We're just doing some division right now.
Okay. Sorry, I have some.
It's okay. So, okay, here is the breakthrough. Now, if you noticed, there's a 0 here, right? So if I put that back, what we're doing is we're actually taking 3 digits and we're breaking it up.
Yes.
1, 2, 3. We do it again here. We're actually taking this whole number, 1, 2, 3, and we're seeing if it works. That was the one pattern I noticed. And I was like, oh my goodness, because this is going to really help you understand when you start putting in that extra 0.
Yes.
Tammy talks like so you've seen this pattern?
No, but I'm understanding how you're going through this.
Oh yeah. Alyssa, Evelyn.
I'm kind of there.
Okay. So when we're looking
But I've
at
been
it,
working on this, so
yeah. Now look, why are we doing that? Because remember, when we do multiplication, this is why you need number fluency. Number multiplication, we know that 3 digits. Why? Because it's 23 times 3, right? Is equal to how many digits? 1, 2, 3. So we know our place value, we're going to go 3 digits because we have
yes,
1, 2, 3
three.
digits. This becomes 0 and this becomes 69. So when we do division, you need to follow the same pattern. It's 3 digits. But for us, for division, we always know it's going to be 3 digits, but we need to figure out if there's going to be a 0 in front or no 0 in front. But you need to know whether it's going to be of the 3 digits. Because why? Because these two digits plus one more, that makes 3 digits. So it doesn't matter how big your divisor is, you always add one more, and that's how big your number you're going to look at.
Lynette, can you?
Change a new paper?
Yes.
No, I appreciate that. I appreciate that.
Yeah.
I appreciate that. There we go.
Got about 9 minutes, Lynette.
Okay. 9 minutes. And that's the breakthrough. That's it. I'm done.
No.
Well,
Okay,
that's
what?
what you want to do. Now, what you're going to do is a different story.
Say that again.
I said it's what you want to do. Now, what are you going to do? That's a different story.
Oh, yeah.
I know, but we're start. I'm just barely starting to get this, and so doing it like on a clean sheet of paper. But what I'm noticing is that we're putting all of our thought processes on the paper, and in my mind, I keep on thinking, okay, I gotta line it all up, and so when it's
Yes.
all messy like that,
Yes.
I'm like,
no, I
okay.
completely understand. Because when I'm because I'm building my multiplication book. This is what I got. Let me show you.
You're building a multiplication book?
No, sorry. I'm building a division book.
Oh, okay. Okay.
So here is the beginning parts of, I'm still working with it. Let me see if I can just, okay, let's do that.
So maybe doing that video actually really helped you then with your book. That one video with the lady when she was doing the blocks and dividing and
Yes,
stuff like that.
yes, it did help a lot.
Okay.
So in the beginning of the book, we still do a review, but I'm talking about cumulative property. So we need to know the two, right? Oh no. Yeah. Do you see it? What are you guys seeing?
I see it.
Okay, good. So again, we're just looking at the missing factors. I wanted to really hone in on what we need to do is understand this part, the times table ladder. We want to minus the 1, we're going to minus the 2. This is what we need to know. I'm going to build this out a little bit better. Okay, so now in the beginning, I show you the parts of the equation. This is where I got the lady. She was mentioning how these are, and I was like, oh, I should do that too. So that's what I did. So I showed the long division symbol. I showed the obless. That's what this is. Obless. I don't know.
I didn't know that.
Yeah.
I didn't know
All
that
right.
had a name.
Yep, that had a name. And then there's
That's
the equation
cool.
sign. So on the abacus, I'm showing you how to divide on the abacus. We figure out where we're going to put our numbers. We have our dividend and we have our divisor. We know our dividend is 3. We know our divisor is 1. Right? So our place value is going to be in the tens column. Got it?
Yes.
So now, how many digits are in the division question? This is where we have to start our starting point. The quotient, I'm sorry. There we go. The quotient is right here next to our dividend. So we put our dividend here. Do you see that? And our quotient sits right here on the 2.
Yes.
You like my finger? I put my finger there just for you guys.
Yes.
Oh, yes. Yes.
So
It's a
notice that
beautiful finger.
thank you.
Yeah.
Actually, at least it doesn't have like the long, what is it? The long fingernails. All right. So here we go. So again, I show you the pictures like I do because I enjoy pictures. So I show you the pictures like I do with multiplication. Okay. Now we go into dividing. Again, our quotient is going to be right here. And then we have to divide it. How many times does it go into 1? That doesn't work. So we have to make it a 2-digit number. 1, 9. We got to bring down the 9. So this is where we go. What is the question? The question is how many times 2 goes 19 or less? It goes to 18. So we add the 1. So our 9 goes here where the quotient is. Do you see that?
Yes.
And then notice I line it up. Our 1 is here. So we take away the 1 and we take away the 8. So when I bring it down, our new number, see, now becomes 1. And then this is still my 8 from before. And then we do it again because we still have dividends. So our new question becomes 2 divided by 18 divided by 2.
So you're right. Okay, because you've broken it down. So now you're redividing again with a smaller.
Yeah, so we redivide again, but you keep
dividend.
Yeah. Okay. So then we do it again. So we have 18. Can't do 1, so you got to bring down, and this is the pattern you're going to see. You can't do it. You got to do it again. You got to bring down the 2. Bring down the 8. Bring down the 8. Yep. And so your answer becomes 99 because I did it again. I add the 9 in my quotient. Notice I move the Q over, right?
Yes.
Oh, I got to say that. I move the quotient over. It's always going to be next to the dividend. Always.
Just like it is in written form on paper. Okay.
No, paper doesn't do that.
Okay.
And that's it. And so then this is the answer, 99. So that's my first concept.
Okay. I got it now.
Yeah. So I understand that it needs to go in order. and I've been trying to line it up. Let me see if I can show you my little book of practicing. Because here it is. Because when we're writing it on paper, it's very hard to see.
It's really messy.
Yeah. So when I'm looking at it, I did 14 and I had to, because I have to write it on paper, but if I did it on the Abacus, it's super easy. But to show you the difference, I have to make sure that it all lines up. I think I'm going to use squares to show you how it all works together. So this is the one.
So like grid paper?
Yeah, I'm
Yeah.
going to do grids and squares. So it's easier to see and follow the structure. But
Yeah.
this is not until book 2. This is book 2 because I do 2-digit division.
Okay.
So book 1 is only 1 digit divided by however many, but book 2 is 2-digit divisors.
Mm-hmm.
Yeah. What do you think, Evelyn?
Yeah, I think this one makes more sense, but it's going to be for higher levels like grade 4, grade 5.
Say that again.
This one with the 2-digit divisor,
Yes.
I think it's going to be better for the grade 4 and grade 5.
Yes. That's why I was working on how to better explain 2-digit division. I have my structure on how I was going to grow my 2-digit division, but it's more complicated. It's more complicated because there's a thing. Do you deal with what happens when there's too much of a quotient, or how do you figure that out?
When there's too much, you just carry it over.
When it's too much, let me see if I can find a too much one. Yeah, I've been working with trying to. Okay, yeah, let's do this one. I think this one's it. 7. Yeah. Let me get you better paper. So 12, 5, 2, 9, 2. Okay. That's my timer. All right. All right. So how many? It's 2, right? Because it's 4 here and it's 2 here.
So it's gonna, yes, 2.
That means it's 4 minus 2.
Yeah. 4
So you
minus
have
2.
A quotient of 2. Okay.
Yeah. So our quotient's going to be here. How do you figure out, Evelyn? How do you figure out where to put it on the abacus?
And we do it on the left-hand side.
So what do you do?
On the right-hand side.
You just put it all the way to the right. So you do 2, 9, 2, 5 like
12,
that.
No, 12.
So that
on the left-hand side. On the left-hand side.
You put 12 here?
We just separate the digits. No, the other way around.
Oh.
The other way around.
So 12 like this. And then you do 5 here?
Yes. And then 5, 2, 9, 2. Yes.
5, 2, 9, 2. How do you know where your place values are?
We leave a rod after, just like you did 4 minus 2. We'll be able to tell how many rods are going to be used at the middle.
Oh, so you're okay. So you still do this part?
4, yes.
Okay.
Yes. So we can now tell
that's
the rods we're going to make use of. That will give us our quotient.
Oh, interesting. Okay. So for us, what I do is I use the quotient. I use the dividend to help me with the quotient.
Yes.
So how do you know?
When they know the number of digits from the left-hand side and subtract it from the one on the right-hand side, they will be able to tell the quotient, which would be at the middle, which is the tens and the units for this particular one.
Okay.
But for the younger ones, they can also do the same. So as they see it, they'll be able to tell from what they are saying.
Oh,
So it's not like
interesting.
it's going to be on paper, it's everything on the soroban. So they're able to tell there are 4 rods on the left, 2 on the right, and then subtract, and then have their rods at the middle.
Oh,
Or on the
interesting.
tens,
Okay.
100 tens or units. Yeah.
Right. Okay. So then, yeah. Okay. So then that means that you know that how many times does 1 go into 5? It would be 5. Is that what you do?
Yes.
So then now if I take away the 5, if I do 2 times 5 is equal to 10, too much. I can't take away 10. So then what do you do?
Can you say that again?
If I now, because I did 1 times 5 is equal to 0.5.
Okay,
How
no.
do you,
No. But that's not how we do it. Because these ones are in the upper grade, we work with not per digit, not the divisors are combined together and worked in that. So we just go straight to, okay, you're starting with 2 digits, so we start with 2 digits as your dividends. So it's now 22 divides by 12. So we don't go from the basis. We already believe that at that grade 4, grade 5, they are already conversant with 1 to 12. On your
wait,
life, you were like, on your life, you said they should be conversant with multiplication up to 9. But with
yes.
us, we do it up to 12.
Okay, right.
Okay, that's the maximum. Then we are assuming they are very, very good with um, repeated subtraction. So we bring it in. Now, let me just explain this in this one. Instead of saying 1 times 5, that's speaking the divisor divided by the dividend divided by the divisor. We
Yeah.
just go straight and say 52 divides 12. How many is?
Okay. So,
Move it in.
okay. So then that's if you do 12, right? What
Yes.
happens when it's like 23?
That's where we're ready because from our own learning process, we believe that at that particular stage, the child should know how to do their multiples.
Multiples
So
of 23?
Repeated addition. So there's
Oh,
always a pattern to it, yes. There's a pattern to it. Every number has a pattern.
every number has a what?
Every number has a pattern.
A button.
So it's a pattern. Pattern. Sorry, where I am is quite noisy. Pattern.
Wait. B
I'm trying
A.
to.
Oh, a back end.
Pattern. The pattern. P, not B. PATT.
Oh, a
T.
pattern. A pattern.
Yeah.
I see.
Yes.
Okay.
So every number has a pattern, and so at that stage, it's believed that they are already used to it.
Oh,
So that's
interesting.
where, yes. So one of the ways we can get that is repeated addition.
Oh, interesting.
Then, okay. So using the abacus at this stage is because they are now very good at each of the patterns of the numbers. So most of the times we use 2 digits for 3 digits when they're in grade 4, grade 5. That's when we're able to see how good they are and drill them on that.
Oh, interesting.
So we use the normal division method on the abacus at this stage.
Yeah.
Nothing different.
So wait, so the 23, how do you tell them to do the division on the 23?
Repeated addition.
Oh, so do you write out a list? 23
yes.
plus.
Now,
oh,
they don't do the repeated addition on paper. They still do it on the abacus. That's those rods that are empty. We use it to fill it in.
So wait, they still do it on the abacus. So if I did 23 and then 23.
Yes. The essence of that is to make sure that they see what they are doing. That's why we place all the numbers in the abacus. So they are able to work on the abacus, do their repeated addition, do their repeated subtraction, and then use their quotient area. So
Oh,
everything is basically done on the soil.
right. Everything is done on the Soroban, which is great.
Yes, not
But
on paper.
but the way no, I do it on paper just to show what we're trying to do. But usually I would do it on the abacus and be like, okay, but the way the method that I'm teaching is I don't do repeated addition for division and multiplication.
Okay.
Because what I'm doing is we're strengthening the concept of the multiplication facts. I write it out so then we can all see. But I can easily do it on the Soroban.
Okay, so how do you do this 23? Let's go with the 23. 8,073 divided by 23. How do you do this?
Well, okay. So when I do it, we don't do repeated addition on the abacus. It's still distributive property like we do in multiplication. So multiplication, we know it's 23 times 4, because we know 2 times 4 is equal to 8. Okay, so I need a new paper. And I'm still here. All right. So the question is 23. So again, we still figure out where we are located. So that part makes sense. We know that we're at the 2. So we're going to do it again. We're doing 8, 0, 7, 3. Okay. And now but here we can't be at the 100. We can't be at the 10s because we know it's going to push us to the hundreds. Why? Because we know that 2 times 0 is equal to 8. But because this is a single digit, we got to make it a 0, 8. So that means instead of here, I go here.
Oh, now I get it. Okay, you take the tens flats and divide by each of the digits.
Yes, just like we do multiplication. Because if you look, we do 23 times that by 4, we do multiplication, right? 2 times 4 is equal to 8. And then 3 times 4 is equal to 12.
Okay.
If you do it for multiplication, you should do it for division, is what I'm telling you.
This makes more sense.
The reason why I don't tell my kids to memorize to 12 because I want them to practice distributive property. So when we do 12, it's still the same thing with 9 times 9. I want them to get that practice that this is 1 times 9 is equal to 0, 9. Why? Because 9 is a single digit. You got to make it a double digit. That's why it pushes everything over. So then we do 2 times 9. It becomes like this.
This makes okay.
So
that's 108.
This is why you need to know whether your multiplication factor is 2-digit or double digit or single digit.
Okay.
It's all about aligning.
Yes.
It's all about aligning.
But it's on paper, you have to align it. On the abacus, it does it for you. So that's the difference. And so when I build my workbook, I'm going to put it in on a grid so you can see it better. This is why it's a 0, 8. Because you go from 8, you're here. But you go here because it's a 0, and you have to recognize it. So that's where the alignment happens, because you need to know that now you're working with these 3 digits. 1, 2, 3. There's a 0 here.
So in your book, can you make it where there's a space to add that 0?
Wait, I'm sorry. Say that again. Wait.
I'm a bit
Alyssa?
confused.
Wait, okay. Alyssa, what did you say?
So when you have it in your book, when we're working, so you're basically saying that whether it's a a 4-digit dividend, you're always going to put a 0 before that first number 8. Can you make room so that you always do that?
Yeah, there's going to be room, but you don't know if it's going to be 8 or if it's going to be, I don't know, 1173. Then you don't know that you're going to be here because this will work out. You know what I mean? I don't know if this works out, but because 1 and 2, you can't do it. So that's why everything shifts over. So it would be 2 times 5 is equal to 10.
Okay, that makes more sense.
Okay, so my question is, the divisor.
The divisor, yes.
That number, like, if your dividend, if it starts out with the first number being bigger than the divisor, then you're fine. But if your divisor, the first digit, is bigger than your first number in the dividend, is that kind of how you're explaining that?
No, it all depends if the product is going to be a single digit or a double digit. So we know, do I have it here? I'll do this. So we know, I don't have answers. So we know, so this is where we really need to know our multiplication fact. You're going to notice that these are single digits. All these single digits needs to be double digit. So we know 2 times 4, 2 is bigger, 8, right? It's the 6 that's going to be a double digit, and it's going to be a 4 that's going to be a double digit. It's going to be 08, 06, 04. Are we okay with that?
Yes.
Okay. So going back to here, so Alyssa, did that make sense? So it's not whether or not this is bigger, because you don't know. You're always going to compare one digit. You don't know if this is going to be bigger than the one digit on the divisor.
Mm-hmm.
So you have to figure out, if you can't do this, there's no multiplication fact to say 2 times something is equal to 1. There's nothing like that. That's why you have to do it 2 digits.
Mm-hmm.
But here, because 2 and 8, 2 can go into 8, that means that I need to add my 0.
Oh,
okay.
Because you're doing distributive property right there.
Yes.
You're taking one digit at a time.
Yes.
Okay.
This is
Yeah,
like
I
a whole
understand it. Don't ask me to explain it.
this is like a whole masterclass.
It's a master of masters. That's what I'll call
Like
it.
seriously.
So I'm telling you right now, I gotta figure out how to monetize on this. Honestly, I think it's gonna be swept away into the ether because I have so much fun. Anyways, okay, so this is why you need to know if it's a double digit or a single digit. If it breaks it into it, but then if you remember, we took away too much. That's why we had to go back. Back to a new piece of paper. So the difference between what I was taught is if we took away too much, we got to add back. Evelyn does it. She does the list. So that's that's what happens with
That takes a lot of time too.
what, to do the list?
Yes.
Yeah, to do the repeated addition, it does take a lot of time. And so when I do it, okay, so let's go back. So 2 times what is equal to 0.8? Remember that, right? So I'm trying to line it up. We know 2 times 4 is equal to 0.8. That gives me 0, 0. So the one I do, 3 times 4 is equal to 12. This is where you line it up. 2 and a 0 is no good. So then you cross this out. But this is where you got to remember, we added a 0. This is actually 20 times 4. There's a lot of concepts here. This is obviously, this is like, you should know this later on, but because we're starting from ground zero and then jumping in. So remember, this is that, right? So what happens is we got to add back. So we took away too much. So instead of doing 4, we got to add back 1. So 2 is actually 20 minus times minus 1 is equal to 20 minus 20. So that means we got to add back the 20. I got to figure this one out better.
Yeah, that part a little bit is confusing. Okay, I do have one quick question.
Yeah.
If we know our multiplication facts and we know, do we have to go to 2 times what? Or is that just to signal us to say that, well, 2 times 4? Is there any way of cleaning that part back up? Or is that where the practice comes in with multiplication?
This is where the practice is, because I'm just showing you step by step. I could easily say 23,8073. I could easily say 2 times 4 is equal to 8.
Yeah, can we do
I could do that. I could do that, but then you break up the pattern.
What pattern am I breaking up?
The pattern that if I take away too much, I have to go back. I have to take away 1.
So when you're saying you're taking away 1, what are you taking away?
So remember the groups of, remember these groups?
Oh yeah.
1, 2, 3, 4, 5, 6, 7, 8. I took away too many groups.
I see. Okay. Yeah, I got to keep on remembering that you're okay. All right.
So if I take away too many groups, I have to only take away 3, and I got to add back the 2.
Oh, and okay.
So
so those two are added back into the dividend.
Yes.
Okay.
Yes.
I see. Okay.
But see, if I do it this way, I don't know. I could do it this way, but ideally, I like to increment it.
Okay, that's fine. That's fine.
Because, I mean, okay, anyway, okay, let's see. Let's try it that way. So we know we have to add back the 2, right? So this is where we go 2. And then 3 times 3 is equal to 9. Remember, 9 is a 0, 9, so it'd be 0, 9. Because you bring that down.
Mm-hmm.
Okay. So now what? Now we know how to take away. So this becomes 11.
Mm-hmm.
Evelyn, you okay?
Yes.
So now we still have more. We're going to redo it. So when I do it on the abacus, I go 8, 0, 7, 3. So I know I'm going to do 4. That's too much. I'm going to take 1 away. I'm going to add the 2. So then I have 3. Take away 3 times 3 is equal to 9. So my new answer is this.
Can you do that again?
8. So there's my 4. I take away 8. See, this is why I write it out. So then you could see what I'm thinking. And I think that's the problem with Abacus World is we don't write enough to show what we're thinking. And I think that's where Eurocentric math is very good at. So we did, this is what we did. Series 7, 3. So we took away too much. We got to add, we got to take away the 1 from here. We got to take away, instead of 4 groups, it should be 3 groups. So you take away 1 from here. So now I have 3 groups, but I got to add back my dividend. So I got to add back my dividend.
That's 20.
Okay.
I'm
So
liking
now,
your verbiage. Thanks.
what's that?
I like how you're saying groups. I like how you say I have to add back to my dividend. Thanks.
Oh yeah. Yeah, you're welcome. No,
Yep.
doing this is really helpful for me. Thank you, Alyssa, for being patient. Okay. So then because I already did the 2, I got to do it to the 3. I know I removed 1 group, right? So now it's 3 times 3 is equal to 9. 9 is a single digit, so you have to go to here in our dividends. So we take away 1, we take and then that's my new number. Does that make sense, Evelyn?
Yes, it does.
I feel like we've done this before. Like this whole feeling, I feel like I've done this before. So now we're going to redo it. Because we still have extra, we're going to recount it. It'll be 23 divided by 100, 1173. And I need new paper. This is why I have a lot of scratch paper too. Until I can get rid of all of my scratch paper, you're going to see 1173. All right. So we're still here. We still have our 3. And then it's just regular. How many? So now we go, how many? So we know what? 2 times 5 is equal to 10.
Yeah.
But it's different now. Why? Because we know that we can't. So, but I like to explain this, right? But anyways, 10. So we have our 5 there, right? And then we know 3 times 5 is equal to 15.
15. And that works.
Take away 1, take away 5. But see, what I was saying is we have to take 3 digits. This is 3-digit columns. That's the pattern.
Oh.
It took me a while to catch on to that, putting stuff back
Yes.
when you use too much.
Yep. When you take away too much, because the way I do division is I want to take us, I'm trying to get to a little bit, but I don't know anything higher than 9. So I'll take out more than I need. And if I need to add it back, I can add back my dividend. And that's it. So then we just look it up.
By doing this on paper, it helps you to keep track because you're visually seeing the number written down, how much you have to put back. And that's why you want to be able to write this on paper. How on earth would you do the problem without the paper?
It's a bunch of mnemonics and a bunch of rhythm. So like that was the problem with Abacus World. Abacus World, I don't know, have you read an Abacus workbook?
No.
Okay. I was going to say, when they redo this, it's really confusing, right, Evelyn?
Yes, it's really.
It's really confusing. So
easy for kids to see.
Yes, and so when I did it in school, when I did it in my learning class, we talk about it, but we don't write about it. This is me writing. This is me making this connection. This is not anybody else. Does that make sense? So what you're learning is my style of teaching, is what you're learning. because nobody else has done it this way.
That would be true.
Yeah. And I was really excited when I found this pattern. And the reason why we do 3 is because we have 2 dividends and 1 quotient. If we had 3 dividends, then you do 4. If you had 3 divisors, then you do 4 dividends. And I see the pattern. And this grows. The more numbers you get, the more you use. And it's so amazing. It's so amazing how mainstream math has made division so complicated. But if you break it up into distributive property, this concept is repeated over and over and over and over again. That's why I always go back to how many times does this go into 10? Because we only need to work with 2, any given time, you only work with 2-digit numbers. That's it. It doesn't matter how big the number is. It just gets a little confusing, that's all.
So basically, they keep reducing it on the Soroban.
Yes. Yes. Just like that. But see, the thing is I didn't teach the kids to do repeated addition. What I got the kids to do is understand multiplication with multiplication. They should know how to multiply their small math facts. That's why I was a little like, I was trying to look at other people, how other abacus teachers teach division, and they still do it the Eurocentric, like writing out a list, or what Evelyn was saying is they do repeated addition. But there is a way to do it abacus with multiplication, distributive property multiplication. And that's what I figured out. I mean, when I was taught, it was more confusing, but I'm trying to explain it better.
Yeah, you're still using the long division.
Yeah, this is still, yes, we are still doing long division. Yes. We just happen to be
They now
taking
see the process. Yes, they now see the process in the other.
Yes. And that was the one problem that
this way.
Yeah, and that's what the one problem with my kids, even to this day, because they don't know this process the way I'm teaching. They know the process of how I was taught, and we were just told to do it. But the problem with that is you don't know why. Here, I'm showing you why we do it. That's the difference between what I'm teaching and what we're learning. What I'm teaching is this is why we do it this way. And then because it's the same pattern, it's easy to see. I showed my one kid. My oldest one has a really good sense of his division. Like I really drilled it into him and he understood what I was trying to say. And he goes, it's a lot easier. My other 2 do not remember their division. And I realized that that's the problem, is because there was too many shortcuts. It was too many, like, I don't know why we did it. We just did it to do it. Whereas I'm telling you, the reason why we do single digit, double digit is because we want to push that over. I'm telling you, the reason why we do this is so then it solidifies better. Okay. Are we ready for one more?
Sure, if you want to.
Alyssa? Evelyn, what do you think?
I think let's finish up this one. Let's finish up this question.
I'm sorry, say that again. This explanation is?
Let's finish up the question we have. 8,033 divides.
Oh, that's it. We did it. this becomes 23. 23. So, okay, so let's go back. Where's my paper?
The quotient is 351, Evelyn.
Yeah, so we had 8. So we did 8, 0, 7, 3, right? We took away the 4, that's too much. So we take away the 1, we add back the 2.
Uh-huh.
3 times 3 is equal to 9, 0, 9, 0, 9. Take the 10 plus the 1. Now we do it again. 5, 2 times 5 is equal to 10, 1, 0, 1, 0. 5 times 3 is 15. Take away 1, take away 5. And then we do it again. 2, 3, 1. Take away 1, take away 2, take away 3. Easy.
Says the teacher. But
But now you see the pattern.
see, I understand what she's doing, but I cheat a little. I use this one to figure out what my number needs to be, so I'm not going back and forth
Yeah,
while I work off of this one.
right. So
But
that's
when you're starting out,
How do you cheat again? Tell me. I had a call and
now
everything.
I've worked out how she's doing when she's doing it distributive properties.
Hmm.
so she does she's doing this on the other abacus.
Yeah, where like 23, then I'll multiply it by 2, and if it's not enough, then I'll do it by 3 till I get
Yeah.
to the product so that it doesn't go over what
Yeah,
I need.
that's what Evelyn does. That Evelyn does that with the kids. They do
Yeah, but I
addition.
do it on this.
Yeah, they do it. They do it over here.
Oh,
They do it
okay.
over here.
Okay.
Yeah.
Oh, that's just basically a track record, is what you're saying.
Yeah.
Yeah, but I'm
Yeah.
cheating. But I have done it. But I have done it the way Lynette teaches, because I needed to understand why she was teaching it the way she was teaching it.
Makes sense. So, yeah, this is a lot to grasp. So, we can keep on doing this. I'm wondering but is this only with the 2-digit divisor, or is this the same, applies to a single digit divisor as well?
No, single digit doesn't have to, because there's nothing to overdo.
Yeah, this applies to 2 or more devices.
Yeah.
Okay.
It's only for 2 or more.
As we're practicing this, can we do it with, it doesn't matter how large or small your dividend is?
No.
It doesn't matter how large or small. Correct. So we can do one right now. Hold on. Let's do hold on.
This just takes a lot to getting used to. What level of division would you say this is?
That one is what level? That's like for 5th grade.
For 5th grade.
5th graders.
Oh, well, okay.
I've been working on it for a good 6 months to get to the point that I understand it. So
yeah, making the double digit, making the 2-digit divisor book is going to be going to take me a little bit longer. But I figured it out. I figured out how to break it up. It just takes me time to figure out where all those questions are.
So, what advice do you have for organizing our mess when we're working out the problem?
I like this. I like the long division sign. I tried doing it with the I tried doing it with this. What do you call it? The obless.
So
I
bless
could
or
I
oblique.
couldn't do it. Yeah,
No, no,
obless
no, no.
obtuse.
This keeps things contained.
Yeah. So I would do it on a graph paper. That's what I do it on. I'd do it on graph paper and I'd use the lines in the graph. That's what I would do.
So you're trying to say that we should, or you're recommending that we should involve using writing in this for division or all parts of division. The arithmetics, addition, subtraction, multiplication, and division. We should try writing.
I don't.
Are you recommending that?
I think.
Because for the division now, I think this writing is a long way. I don't know about the others. Are you going to recommend that we do that for the division or other arithmetics?
I don't. For the kids, I don't know if the kids need to. The teachers need to write it. So a teacher needs to show what we are trying to say. Does the kids need to? No, they need to understand what we are trying to say. That is why I write as much as I do. Everybody, because I could tell you everything and it doesn't matter. If I show you and write it for you, you can see it and understand it. So as a teacher, yes, write it. For a student, they don't need to write it. They just need to figure it out.
Yeah,
You know what I mean?
that's for the last 6 months I've been working on doing the problem on the abacus instead of
Yeah.
writing it down.
Yeah. Because it
That's
gets confusing. Yeah.
yes.
It
So I
gets
said last 6
confusing.
months.
Yeah. It gets confusing for a child to write this out constantly. But for an adult teaching, you need to write it out. So here, we would figure out 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then take away 1.
Yep.
So
Yes.
do
I was
3,
wait a minute now.
1, 7, 5, 7, 6. How many times does 7 go into 31? 7 times, I don't know, 4?
Four should be 28.
28, right?
Yeah.
So put 4 here, take away 2, take away 8, take away 8, right? See, I'm not,
Yes.
you could do that, but then the problem is the kids should know. By here, they should know how to do their the plus 5s and their 10s, right? So we have 37 left. How many times does 7 go into 37? 5. 35. So we have, what's next? We have, see, now you see the pattern. You only do 2 numbers at any given time. 25. What is it? 3? 21?
Yes.
Right? And then we do it again. 4 and 7, 47, 6. 42.
42.
Yep. And then 56 is 8.
So you've got
Oh yeah. 4, 5, 3, 6, 8. Yep. But it gets hairier when the dividend gets bigger. So Alyssa, so it doesn't matter how big your dividend is. I'm sorry, your divisor. It gets hairier when your divisor gets bigger. So you can do all of this, whatever you want. It doesn't matter. With single digit, it's the greatest. It's so easy.
it is.
Right.
Okay, so Tammy, explain to me what you have been doing on the side.
Nope. Nope.
Oh,
Not until you get this down, and then I will explain what I do. No, ma'am.
Oh.
So
Hey, it took me 6 months to get to this point. So
It took you
Okay.
6 months? Okay, so what was it like at the beginning and where you're at now then?
Where you're at.
You're not being nice to me. Okay, all right, I got it.
What the confusion you've got is where I was at. I'm like, I would look at, I would say, Lynette, what?
Okay, so I am where you once were, is what you're telling me.
Yes, very much so.
Okay, all
Okay.
right.
So this is the last question. This will be so easy. How many is it? Where's our starting point? 4.
You
This is
got
4.
5 and 4, so it's 1.
So it's 1.
Okay. So we're going to put 1. 1. So 3, 9, 1, 1, 7.
7. Correct.
Evelyn, this is why we need to know if it's a single digit or a double digit. Because now we know 3 times 3 is equal to 3. 3 is a single digit, 0, 3. So you go over here. Your quotient will be here instead of here. Does that make sense, Alyssa?
Mhm.
Yes, it does.
So 3 times 3 is equal to 3. So I take away 3. 3 times 1 is equal to 9. Take away 9. 3. Oh, no, sorry. 3 times 3 is equal to 3. Ha! 0 times 1 is equal to 0. 0 times 1 is equal to 0. 0 times 1 is equal to 9. Minus the 9 is minus the 10 plus the 1. Got it?
Mhm.
You okay?
Mhm.
Yes.
All right. So we have our new number. I'm going to rewrite it. 3009 9027. How many times does 3 go into 9?
3.
3.
Right.
3 times 3 is equal to 9. Again, 0, 9, right?
9.
0, 9. So
Yeah.
3 goes here. 3 goes there. 3 times 3 is equal to 9. 0 times 3 is equal to 0.
Yeah.
0 times 3 is equal to 0. 0 times 3 is equal to 27. That's it.
Oh.
So my answer is 13.
Oh. Okay. Because 0 times is always okay. All right.
Was that
I,
easy?
I have to not look so overwhelmed because as soon as I see the numbers, I totally shut down.
Yes. Yes. But see, the thing is that's why it takes time to curate the questions. The questions need to be curated. The questions need to be what do you call it?
Mastered.
No, the questions need to be picked wisely. I'm not going to give you a bunch of numbers that doesn't make sense. So this would be like the beginner because it's so easy. It was like butter. And so then the next step,
But really, the question was really tricky. Because of the
what?
way it was. The 3009 and the
Yes, yes,
39117. It was,
yes,
it threw me off balance too. So
yeah,
when you're giving kids, basically you're saying when you're giving kids question, you should be sure of the answers and they should be simple so that they can
yes,
see a reason to use
yes,
it.
yes,
So give
yes,
them confidence too that they can actually do the problem.
yes. But as a teacher, you should explain every step that you are thinking because that's what the transfer of knowledge is. That's the transfer of what we're trying to do. So talking to adults has really helped me explain why we do the things we do. That's why I'm telling you right now, hands down, I learned so much more at teaching because you guys are asking why. Kids don't ask why. If kids don't ask why,
That's all.
you know, that's the problem. That's why it's good that you're going live, Evelyn, so people can ask you why, and you'll be like, I don't know, it just happens. But now you need to know. You need to
Now you know the
explain.
whys, and so now you can explain it.
Exactly.
It's
I
still
now,
overwhelming though with the yeah, because I think I mean I feel like my brain is like going back into a little kid mode, and so
it was a
um,
lot.
it's
I'm
it's a
just,
lot.
I'm just super excited that I got division. And I'm just letting you know, I feel like my division book will be phenomenal. I'm just
Oh,
letting you know.
I'm just waiting.
Yeah.
You know me, I'm just waiting.
Because
But
the amount of time, yeah, the amount of time that I've been thinking about, like, it was a game changer to make multiplication. It's going to be another game changer to do division. It was another game changer that I did grade 2. And when I do grade 3, grade 4, grade 5, those are all going to be great game changers, because it doesn't matter what grade you start,
Nope.
you can always go into Abacus.
Yep.
So
yeah,
I'm very excited.
So after a while, what it really is I I don't think really grades really matter. It's the elementary years,
Exactly.
and
Yes.
it's basically getting your fundamentals down.
Yes.
So
Yes.
that's what all this is all about, is getting like just like that little video that I, when I took it, because I'm visually watching you on the abacus, and I'm thinking, okay, I'm following you, but
Yes.
because my brain is on overload, I was like, I forgot that those zeros, when you're multiplying it by any number, it's going to be zero. So
Yep. But you
I mean,
have to move.
yeah, and that you have to move. So, but yeah, I mean, there's this extra step, and that is being able to do that on the abacus. I mean, that's a whole nother level.
Mm-hmm. Mm-hmm.
So,
what and the thing that got me was when I realized you're only dealing with the one number
Two.
or two numbers, excuse me. You're
You're
dealing
only
with
dealing
two
with,
numbers.
yeah. At any given time, did you notice that, Evelyn? At any given time, you're only dealing with two numbers. You're either dealing with a 10 or you're dealing with the ones. It doesn't matter. Even when you do grouping and regrouping, you're only adding a 10. That's all you're doing. You're taking away a
Yep,
10 and you're adding a 10. But you have
yep.
to explain this to the kids.
mhm.
You don't get the kid. This is how obvious I want you. I want you to be as obvious as possible. You're only working with two, because the problem is mainstream math doesn't, they tell us there's the whole picture. You got to figure it all out. But Abacus brings it down to manageable chunks. You only need to know what's in these two columns.
Yeah.
Mhm. Yeah.
It was like a serious light bulb went off when I realized that.
Yeah.
Mhm. So, like by me explaining to Abram that little concept of the chaining part,
Yes.
he was able to, I mean, yes, we're doing abacus, but he was able to find the patterns and do that in his head with that 99 plus 99 or
Yes.
999 plus 99. Because that, I mean, we went to 19,000 and something. I don't know what he was doing, but he was just mental. He was catching the pattern, and he would tell it to me fast. And then, of course, I was on brain overload. This is at 10 o'clock at night, and I'm like, now, how did you get that again? Well, I
Yep.
just brought this over, and I'm just like, okay. So,
Mm-hmm.
I mean, that it's really good. He's getting a good number sense.
Yes. Yes. And he will be way faster than all of us put together.
Yeah,
Let it go. Let him do it.
Yeah,
If he can explain it, let him go. Let him do it. Unless
yeah,
the answer is wrong, then you take it slower.
yeah.
But don't slow him down.
No, but I am gonna go back when we because what we did is we just took. I said these problems we're gonna do it on the abacus,
Oh
and that
yeah.
little sheet of paper that I showed you where it kind of went step by step progression.
Yeah. I did that
That's
for you.
yeah, and that's what he did on the abacus.
Good, good. And he sees the pattern. Did she go off?
she's
Hello?
still there, but I don't know what happened to her.
Yeah, something happened to the mic. I don't know, Alyssa, if you are still around, but your mic is off. Yeah. And so there was one where it was like it was just like it was a step. Let me see if I could find it. And I explained it, and it was good that the Avram did it as well. Let's see if I can. There we go. Let me show you what it looks like. Hold on. Oh, she logged off. So I gotta find it. Oh, it's over here. Documents. So it's this one right here. So it's just a picture. Is that what it is? No, it's this one. That one. That was a beta picture. And it was just that you start here and then you move your way up. That's all. And you start here and you move your way up. It's easy. Yeah. Okay. So I'm really excited for division. I'm just letting you know.
Oh, you're excited about all of it.
I think that the biggest thing is like the epiphanies that I've come through. And I'm like, oh my God, this is why we do the things we do.
Yes.
So, but I hope the division makes more sense, Evelyn. I hope you can teach the kids to not do repeated addition.
Yes, I'm going to really work on this because I think this is going to be much more easier for you to understand.
Yes,
Because
yes.
now they are working with numbers that they are conversant with, not numbers that are so large for them to become overwhelmed with.
Yes.
So this pattern is much more better.
Yeah.
And even if we want to still place it on the side, they can still work it out just using the pattern given.
Yes,
so it's much more easier.
If I could mention, I would start them to do distributive property at 10, 11, and 12. So instead of having them memorize the 12 times table, get them to do the distributive property with the 12 times table. America
10,
is starting
11, and 12.
Yeah, America is no longer getting the kids to memorize anything higher than 10.
Okay.
So I don't know if you want to go down that route. Abacus already doesn't do it. I don't know if the people that taught you Abacus told you to do it, but I was like, there is no need for me to memorize more than I have to.
Yeah.
I don't want to memorize more than I have to. And so I would practice with the, 11 times table, the 12 times table, 13 times table, and slowly go into that. That's where my multiplication book comes in. Yeah. Okay, Alyssa, you were saying something and then you logged off.
Well, I don't know. My computer's still kind of acting really funny right now. So.
Okay. Yeah.
But yeah. Anyway, I forgot what I was saying. Just because everything kind of messed up. This has been good. I think it would be to maybe as we're doing this, maybe do an example of just doing just practicing it more and more and just reiterating what the zero. I don't know if it's a leading zero or whatever. Just kind of.
It is a leading zero. That's a leading zero.
And what it means. So that would be awesome. I'm really happy. So you're basically saying your one digit division book, you have that completed, or
Not yet.
Not
Not yet. I got to format the grade 2 book 3. I got to format that and publish it. Once that's out the door, then I'm going to work on the 2-digit multiplication. I got part of that going, and then I also got part of the division the division book going as well. I know the division book is a must because there's a lot of people that has purchased the multiplication book and they need that division book to supplement.
Okay.
It's just
okay.
that, and that was the thing, is like I had to really figure out how to explain it and write it down. And so I hope
yeah.
what I showed you made sense.
Yeah. It is. It is. Sometimes I wish I could have like a physical one-on-one. I'm sitting right next to a desk, and you're sitting right next to me, and we're just working these out. But I know that's not the way it can be, and so I'm like I said, I'm really grateful for that aha moment that I had, and just slowing things down for myself. So I think if any of us, if we're learning something and we can like record back and to you, then I think that's an awesome thing, because then it actually something
Makes
has
sense.
clicked and made
Mhm.
sense.
Good.
And so now I can do that, and I will have Avram practice those 99 plus.
Oh yeah, I was showing that.
Yeah,
yeah, it'd be good.
Have him practice that to know how it is translated to, +1. Yeah, that. Yeah.
Yeah. No, but do the 95 plus 3, or no, 95 plus 7, 95 plus 8, 95 plus 6. Yeah.
Oh, those. Okay, kind of continue on with that.
Yeah.
Yeah. I said we're going to do that abacus wise.
Yeah.
I just
that
kind
should
of tell
be.
it to him. We're going to do it abacus wise, and then we started practicing it, and after I showed him a couple times, then he started to understand what the +1 and how it was +1 is plus the 10 minus the 9.
Yep.
But he doesn't have it quite there.
That's fine.
But we'll just keep on practicing, Do you put that in your books too? Where you have the 100, 100 minus a certain number, and then the 99 plus, because that's where all the numbers are used on the, all the beads are used up.
That's not until after the, that's like considered advanced. That chaining equations is considered more advanced.
It is. I'm going to still work on teaching that with him, because he's going to come across a problem. Anyway.
That's fine. You can teach him, but I'm letting you know that that's in abacus world, that's considered more advanced.
Okay, I'm not going to tell him that.
No, you don't need to tell him. You can continue your path, but I'm letting you know as a parent that that's a little bit more advanced. So if he doesn't get it, if he doesn't get it, just keep practicing, because that's all it is, really. You just need to practice. That's all it is. Just keep practicing.
That's exactly what I did. So I was able to regurgitate back an advanced concept. So that's okay.
That one is going to be in book 3, grade 2, but that's towards the end of the book.
Oh, okay. I will still, because he's all about patterns. He picks up patterns pretty quickly. So I'm going to continue whenever we approach a problem where it's 99, whatever. We're going to just work on that, because then he will know that +1 is plus a 10 minus 9. And then you can be flexible with that formula by, okay, well, what we're going to do, what we visually see, we minus the 9, and then we just add the 10. So, so I'm going to do that with him.
Yep. Yeah, that was going to be part of book 3, grade 2.
Okay.
Because that's the advanced part, chaining all of those equations, because that's another chain. That's why I call it chaining as opposed to mixed formula or 2-step, because it's no longer 2 steps.
I like chaining better.
I like chaining better too. Yeah.
So.
Yeah.
All right. So got to go, people.
Okay. Yeah.
Hey, thank you.
I'll see you later.
I'll see you next week.
Bye.
Thank you, Evelyn.